Hey guys, we'll get started here in just a couple minutes here, a little early. But if you can, go ahead and check out the screen. We're going to log into Canvas, make sure we go ahead and start our stuff. So.
Mr. Ken, how is your break?
Yeah, I heard something, but I didn't catch it.
Mr. Ken, how was your break?
It was good.
Winter break.
You do anything fun, Matt?
Not really. I just sat at home all day, mostly.
Yeah, pretty much all I did too. All right, good morning, guys, gals. If you would, hopefully you can see my screen, and hopefully it's showing you your note for today. While we get started, go ahead and log into Canvas and complete the daily check-in. And then go ahead and grab the note for today. I'm finna take attendance here in a second. A lot of kids in. All right. We got most people here. Not everybody yet, but most people are here. All right. Somebody do me a favor in the chat box. Tell me, what do you see on your screen right now? Do you see the Google Slide notes? Or do you see my picture? What do you guys see? All right, good. All right, that's where we want to be. All right, we'll get started here in just about 1 minute. Want to kind of get the last couple stragglers in here. Yeah, make sure you do your daily check-in for me. Go ahead and do that. All right. Okay. All right. Hopefully you see me now. Welcome back. Hope everybody had a good winter break. Want to kind of talk a little about expectations for basically the rest of the school year. If you guys have any questions or anything, feel free to you raise your hand or put them in the chat box. We can try to answer them best I can. I already got a few emails today about whether you have to be at your meetings all day, every day. Yes, you do. There's no more opting out. We are back to normal school. We're back to normal classes now. In December, we were doing remediation, stuff like that. Now we're back to normal school. So you do need to make sure you are attending all your classes like normal. Your teacher should have some schedule or a place to go check out your links just like before. But make sure that you are aware of that you're pretty much going to be on computer between now and 2 o'clock. So you're kind of making sure you are aware. You will have a lunch break like normal. I think your lunch break is at 11:45 to 12:15, which is during core 4. And all engineering kids will kind of take a lunch break at the exact same time. The idea is that this is very similar to a normal school day. So whether we're virtual, hybrid, or in person, this is the same schedule we'll follow every day. Okay, and so hopefully you watched that video of me explaining that before. But basically, we're back to normal, and we're going to have normal classes and stuff like that. So the very first thing I want to check out is your weekly schedule. So I'm actually going to pop that up real quick. And then we're going to take a quick look at the weekly schedule and kind of make sure that we understand what is going on with that. So hopefully you can now see the weekly schedule here. So on the weekly schedule, again, you have an overview, kind of just me explaining what's going on for the week. But things are going to be a little bit different than what they normally are. And so I just want to make sure that we're okay, we understand what's happening. So every day we're going to have a check-in like we normally do. So in class today, note that we're only going to cover a couple of slides, 1 through 13 today. Then we're going to do a little activity part A, and then we might do a wrap up and question and answer session. I did go ahead and record some of the sessions, me kind of giving you the notes. Very first thing you need to do is go ahead and click on weekly note found here. These are going to be your note for the week, and these are now your notes. If I were you, I would actually make a copy of this and put it in your Google Drive, and you can even write on it, do stuff on there as you want. Obviously, all of our links for our meetings are on here. So if you forget where you need to go, just go check out the weekly schedule. Just click on that link and it'll send us to this meeting that we're in right now. So Tuesday and Thursday, we're going to be doing professional habits, some other little different things. So Wednesday, we're going to continue with the notes, but we're going to do the other slides 14 through 21, another activity. And then Friday, we have a quiz on Friday. Now, it's important that you guys understand that. So now, each week, you're going to have an activity that we need to do, and then you're going to have a quiz every week, every Friday. So this is kind of similar to what Mr. D does in his class, where he kind of gives you guys the information that you guys need, and then you guys have a quiz at the end of the week, talking a little bit about that content. The quiz will be locked until Friday morning. You'll have some class time to do the quiz. And then the quiz is due Friday by 3 o'clock that afternoon. So real quick, in the chat box, or raise your hand. Anybody have any questions for me so far? Nothing? All right. Let me double check my attendance here. I'm going to go ahead and post it. Going. How you doing here? David Garvey's here. Peck. No Peck. So Lindsay Baker and. Okay. All right, Lindsay just joined. All right. McBee. All right, so no McBee and no Peck. So I'm missing right now. I'm gonna go take attendance real quick. All right. All right, so we're going to start off with some notes. As always in any class, when we take notes, I encourage you guys to participate, encourage you guys to ask questions. Then we'll go from there. I also encourage you to actually take some notes. On Friday, you're going to have a quiz, and you want to make sure you're kind of learning this material. I will do my best here to deliver good content for you and let you do a little activity. A lot of the stuff that we do on the activity will also be in the quiz, so we want to make sure we're doing a good job with the activity as well. Okay, so we'll talk a little more about the activity later when we actually start that activity. So, very first thing I want to do is share my screen with the note for today. And hopefully, and so here we go. And we're going to go all the way back to the first slide. So this week we're going to be talking about electric chargers this week. And so at beginning or back in December, before we had our remediation weeks, you guys remember we were talking about forces and types of forces and things like that. And so we're going to get into another type of force. It's called electric forces. So the plan for the week today, we're going to do a little bit. Then activity part A, Wednesday, a little bit, activity part B. Take a look at Friday's schedule real quick. We are going to cover some notes, and you're going to have a quiz on Canvas. So with that being said, it's important for you to look over your notes before Friday. So you have them. These are all your notes. Look over your quiz before Friday so that you're ready for the quiz. I am going to go over the last couple of slides on Friday, but then you're going to have a quiz immediately after. So just kind of be aware of that, that the quiz is going to happen really quick after our notes on Friday. All right, so today's lesson, And again, I encourage you to have some notes, write some of this stuff down. Most important concept we'll be addressing today is that like charges repel each other and unlike charges will attract each other. Okay. You guys probably heard that before in middle school or other ways, especially think about magnets and things like that. Very similar. It's a force charge. And so if you have two positive particles, they will repel each other. And if you have two unlike charges, if they're positive or negative, they will attract one another. So you have a picture there kind of showing you what's going on there. If you have two particles that are positive at the top, they're going to move away from each other. If you have two particles that are negative, they're going to move away from each other as well. Okay. Now, a lot of people know this. A lot of people have heard this before, the opposite attract, same repel. But what we're going to kind of get into for high school physics is what does that mean? What does it mean to be positive? What does it mean to be negative? Even, some people already know about proton, electrons. We're going to talk about those today too, but how do scientists know that they are positive? How do they know that they are negative? That is actually kind of a weird concept, and it's something that we actually need to think about and take a look at, because there is a way that something is positive and negative. Kind of has to do with the behavior that the object has. So I just said a second ago that most people are aware that all atoms have positives and negatives. Positives are a proton, and our negatives are electrons. Okay, and so the atoms also tend to have neutrons. Neutrons are neutral. They do not have any charge at all. So the question I have for you, real quick here, and you can even type it into the chat box if you want, is how is it possible that a bunch of protons can be stuck in the nucleus really close to one another? And so think about that for a quick second. Go ahead and give me some ideas in the chat box there. How is it possible for a bunch of protons to be stuck together in the nucleus? All right, guys, make sure you're participating. Write stuff down. Answer your question. So the protons are all positive. They want to repel each other, right? But how is it possible they can all be together? Leslie, you're not wrong on that. What are the neutrons doing? Not sure what you mean by that, Ben. They are, Jackson, but the protons are also repelling each other in the nucleus. Why are they all bunched together? Protons are positively charged, so they will all repel each other. Matt just owns up to it. I like him, man. So going back to that question there. Let's see. But the neutron, so going back to this lesson here, so neutron to neutral, they don't have any attraction or repulsion to the positive and negative charges. So the protons are all tightly packed together, okay, and they want to repel each other, and they do repel each other. What ends up happening though is that in order to put two protons together in a nucleus, or 3 or 4 or 100, is that you need neutrons in there to kind of act as a glue. And somebody said it, but the neutron kind of act as a force holding the proton together. It's called strong nuclear force, and very similar to gravitational force. Neutrons and protons are about the same size, and so they have a force of attraction on each other as gravity, or similar to gravity, and we call that strong nuclear force. But no matter what, even if you get too many protons together, it doesn't matter how many neutrons you put in there, how much glue you put in there. Eventually, the proton will that force of attraction will be too strong, and the atom will start to decay or fall apart over time. And so we call that radioactive decay or nuclear decay, where the atom just gets too big and it just starts falling apart because all the protons want to repel each other. So you can put a couple of protons together as long as you have neutrons. You can put, honestly, the number up to about 90, 92 protons together with neutrons all holding them together. But after you start getting past 92, 93, you just start getting too many protons together. And these are elements that you probably heard of, things like uranium and plutonium. Those are elements that are radioactive and they're just unstable because they have too many protons pushing away on each other. Okay? Now, as long as you have the neutrons, you can't have an atom or a nucleus. And then the electrons are flying around the outside. So another question we ask is, why are the electrons flying around the outside? Why don't the electrons fly into the proton? But take about 30 seconds, type it in the chat box. Why are the electrons not flying into the proton? Aren't they attracted to each other? What do you guys think in the chat box? Why aren't the electrons flying into the proton? Yeah, but why, Logan? No, the neutrons don't do anything. The neutrons are neutral. Hannah, you're really close. I mean, it's similar. Well, Ben, it's electrons are negative, Ben, so they would be attracted to the proton. So they want to go. They wouldn't want to fly into them. They wouldn't repel it. They would go in. Yeah, I know about that one. All right. So Hannah was pretty close. That does happen, we have electron shielding, but that's not really that fun. No, the neutrons don't repel anything. The neutrons are neutral. There's no repulsion or attraction. So the electrons are not flying into the protons. They want to. They should. Remember, opposite charges attract. So electrons negative. They should be going into the proton. But they're not doing that because the electrons are moving around the atom and they're moving at the speed of light. So they're moving very, very fast. So that's the reason why they do not get flying into the proton. It's kind of like an orbit, like the Earth going around the sun. If the Earth stopped moving, it'll be bad news for us. But if the Earth stopped moving, the sun gravity would just pull the Earth right into it. Okay. The reason why the Earth is not going into the sun is because it's moving away from the Earth at the same time. And so the atom is kind of doing the same thing. So without the positively, negatively charged atom, the attraction and forces, we would not have atoms at all. The atoms would not be staying together. The atom would just be all over the place, so there's nothing holding them together. Okay. All right, so we also need to talk a little bit about how matter can become charged, because that's what we're looking at today, is how things can become charged. So matter can become charged when the atoms gain or lose electrons. And electrons are what we're aiming for here, okay? We're not going to lose or gain protons. We're going to lose or gain electrons. Okay? So if an object gains electrons, then that object is going to become more negative. Okay? The opposite of more negative is less positive. We think about that. If the object loses electrons, it's going to become less negative, or it's going to become more positive. And so objects, especially you and me and all of us, they can become different charges. So we're actually going to take a quick look at a demo here Do you guys see this balloon and sweater demo? Put it in the chat box for me real quick. I just want to make sure. Yep, I got it. All right, so you guys have seen this before, or you've probably done it before, where you took a balloon and you rubbed it on your head and things start to happen. Well, all of these objects here that you see, you got a sweater, balloon, and a wall, they're all neutrally charged. They have the same number of protons and electrons. Well, when I take that balloon and I start to rub it on objects, the balloon being latex or rubber, it likes to accept electrons. And so it will gain electrons, and the balloon becomes really negative. Look at all those negative signs on it. The shirt now is more positive, so it's got a lot more protons than electrons on there. And this does happen. So now the balloon becomes charged, the sweater becomes charged. The balloon is negative, the sweater is positive, and so if I let go of the balloon, it wants to be attracted to the shirt on there. Okay? And you guys probably seen that. If you ever do it with your hair, the balloon will be attracted to your hair, and your hair can actually go flying upward, all crazy, going toward the balloon. And that's essentially what's going on. If I have another balloon and I get some electrons, if I put these two balloons next to each other, they don't really want to be next to one another because the same charges will repel each other. Right? But the balloon does like to be next to a sweater because opposites are attracted to one another. Yeah. So if we go, we can also have something that's called induced electric charges, and that's where a charged object can be attracted to a neutral object and not lose any electrons. So we call that an induced charge. So if you think about the balloon sticking to a wall, let's go back to that real quick. This balloon is sticking to the wall over here because it is inducing a charge on the wall. The wall does not have a charge. The wall is neutral. They have the same number of electrons and protons. Even when I do this, the wall is still neutral. Okay, it didn't lose any electrons or protons. Okay, but when I get this heavily negative balloon next to the wall, it's going to push the negative electrons away from it. You see those electrons get pushed away. Then that creates an induction or an induced charge. So this area of the wall now becomes positive. The balloon is still negative, right? And so the balloon can be attracted to the wall or this neutral object because it's pushing those electrons away from the balloon itself, but not taking them away. The wall is still neutral, and so that's called an induced charge. So that's something that that's kind of important to kind of understand and know, is that charged objects become charged by losing or gaining electrons, and then they can be attracted to neutral objects as well. All right, so here's the big thing for today: is what does it mean to be positive? What does it mean to be negative? And this is kind of important because this is how scientists know that protons are positive, how electrons are negative, and what it means. Because again, a lot of kids don't understand exactly what it means to be positive. They just like, what does that mean? It's just a name we gave it. And it is. That is just a human name we gave it. But what it means to be positive, what it's doing with the field. So all charges, positive, negative, have field that they produce. And those fields go out away from the object. Okay? Just like a magnet, I can attract things from a distance. Okay? The stronger the magnet, the farther distance I can attract that paperclip. Well, electric fields do the same thing. Okay? They go out and away from the object. And they interact with things. Okay? Just like that balloon was interacting with the sweater from 3 or 4 feet. That field is going out to the sweater. Well, positive fields, and this is really important here. When the positive field, the field goes out of the object and away from it. Okay, you guys see the arrows going away from positive fields, positive charges? And the negative charges, the fields come inward toward the object. Okay? And so that's what it means when something is negative or positive. What's the field doing? Is the field going outward or the field going inward? Okay? And so if the field is going outward, that's a positive object. So scientists call it positive. And so protons are positively charged because the fields are going outward. If the fields are coming inward, those are negatively charged. So if we look at these drawings here, if I have two fields and they're both going out, that one proton, its field doesn't want to go to the other proton because the proton wants the field to go away from it, right? So those two protons are going to repel each other, but never actually going to touch. So their field are like, no, we want to be away, we want to be away, we want to be away. Whereas in this case here, we have two particles with the positive and negative, the positive field going outward, the negative field going inward. They're like, yeah, let's do this. We want to be together. We want to be attracted to one another. Okay? And so that's what's going on here with the positive versus negative. Hopefully that makes sense. All right. So the last slide for today, or for note, is that when you put a charged object into an area, or what we call a field, if there is a field, so if there's a positive or negative field, then that object is going to do something. So think again, the easiest way to think about it is a magnet. If I have a magnetic field and I put a paperclip in here, the paperclip is going to do something, right? Well, in a magnetic field, or in an electric field, okay, the same thing is going to happen. If I put a charged particle in an electric field, it might be attracted, it might be repelled from the field itself. And then we can make that do work. We can make it do stuff. Okay, for example, we can do electronic switches and things like that. I can make the current flow one way, I can make the current flow another way. I can make it do work for us. Again, the other thing is really important to make sure we understand is that they do not need to actually touch each other. Okay, those are field forces. They can interact with each other from a distance. Okay, the stronger the field, the more distance it can have on impact on the particles. Okay. So today we're going to investigate electric fields and the particles together. On your PowerPoint slide, I have you some additional notes to kind of maybe help you out with your quiz. I'm not going to go over those, but those are actually really good videos that I like. And an article about particles as well. All right, so today we're going to do an activity. On your weekly schedule, you will find part A. So if you guys want to click on that worksheet, open it up together. I'm going to give you guys about 10 minutes to work on this together. Okay, and you guys are going to work on this together in breakout groups. So let me pull back up my Microsoft Teams here. Okay, so when we do breakout groups, it is expected that you guys are interacting and talking to one another. Okay, and again, you don't necessarily have to show your video and stuff, but you do need to actually work together. Okay, if I put you guys in a breakout group and your classmates say Johnny didn't do anything, Johnny didn't help me, well then I'm gonna have to have a talk with Johnny about his work and his grades and things like that. Okay. When we do this activity together in breakout groups, you also need to make sure that you are not copying one another or anything else like that. Again, if I see work that's word for word, everybody involved will get a 0 and have to redo it. Okay? Even if it wasn't you that was cheating or copying, everybody's going to have to redo it. So we're going to go into breakout groups here. When you are in a breakout group, I can see everybody. Okay, so I won't be in the group with you. I can bounce in and out of your groups, but I can see what you guys are working on and things like that. So make sure you guys are working together. I would encourage you to turn on your camera and actually talk to your friends during these groups. Okay. All right. So I'm gonna give you 10 minutes, and let's do 8 groups, and we're gonna create. All right, hold on. Let me fix it. I don't know where it is. All right. All right, hit the refresh button. It should work now. All right, you're gonna go off to the breakout group. There you go. All right, all right, guys, gals. Hopefully everybody's back here. So it's 8:45. It's technically the end of period one. I know we probably didn't have as much time as we wanted to on that. So tomorrow we will work a little bit on that breakout or that assignment tomorrow. And then we'll do our professional habits assignment as well tomorrow. So tomorrow we'll spend about 20 minutes on that and then go from there. Again, you guys have everything you need. You have the notes, you have the activities, you have the additional resources. You can work on this whenever you want. This activity, part A and B, are due on Friday. But again, we'll do part B in class on Wednesday. So anything that we don't finish on these days like this, um, please consider them to be homework or opportunity to get some stuff done. But again, you have everything you need. Work on it, and then I will see you guys tomorrow. Make sure we're on time so we can take attendance and everything. Get started a little bit quicker. Okay. All right. I'll see you guys tomorrow. Again, if you have any questions or anything, please let me know and just send me an email or message, and we'll answer the questions. So good work today. I know that was kind of weird, trying something a little different, and I'll see you guys later. So have a good one.
Question.
Yes, sir, Dylan.
Are there still like 5 minutes between each class before we have to join? All right, I just want to
Yep. Yep, your next class will be at 8:50. All right.